Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here coming with a fantastic chemistry video, and today we're going to talk about this mechanism right here, so let's get into it. All right, we have looks like a secondary halide with methanol, polar protic solvent, heat, and two different products. Now let's take a look at the products real quick. These are definitely substitution products because we're substituting the chloride for something else, right? But now let's number our carbons here. Let's see, carbon 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. Well, look at what happened here. On carbon 2 has the chlorine. Carbon 2 has the chlorine to start. But in one of the products, carbon 2 has the ether. But in the other product, carbon 3 has the ether. So we're going to have to explain that. The mechanism or mechanisms we draw are going to have to explain that concept. All right. Now, at this point, don't think ahead. Just do what you know is right. This is an SN1 reaction. So we're going to make the leaving group leave. We're going to form a carbocation. Just follow what you know to be right, and the rest will fall into place, I promise. So let's just do what we know is right. Let's make the leaving group leave, and we'll go from there. The leaving group leaves. The bond electrons go to the leaving group. The leaving group leaves, forms a carbocation. I'm going to draw it way over here, so I have lots of room. Plus charge is now there. There's a cation on that carbon. Well, we know that the solvent will attack the carbocation. We know that will happen for sure. And then more of the solvent will come and deprotonate it, and it'll give us right away one of our products. So we're already halfway there, right? Oops, let me use blue is the color we're using for arrows. Okay, there we go. And that'll lead us to our first product, and that's good, right? So it's good to get one out of the way. And that gives us that product right there. So we figured that one out. Now, I always tell students, whenever you see something like this, it's an SN1 reaction, or SN1 or E1, they both form carbocations. So whenever you see this, and you have this odd-looking product with the nucleophile on the wrong carbon, look for the rearrangement. There's more than likely a rearrangement. Remember, carbocations are prone to this. They can rearrange if they can rearrange to a molecule that is more stable. Oh, sorry, not a molecule. If they can rearrange to a intermediate that's more stable. So here, if we look at this intermediate right here, it's secondary, right? Let me draw that again. And one piece of advice when you're doing mechanisms is do not draw too much on one structure. I'm not going to draw another mechanism on this structure because I've already got a mechanism drawing on this structure. I'm going to redraw my intermediate so I don't have to worry about having a too congested drawing. All right, so now we have hydrogens on this carbon, right? And these hydrogens are classified as benzylic hydrogens. They're on a carbon adjacent to a aromatic ring, or a benzene ring, so they're considered benzylic hydrogens. This is a secondary carbocation. We all know that benzylic carbocations are more stable than secondary. So that means that one of these hydrogens can migrate or rearrange to that carbocation. That's what it means. Now that's an important thing. When we do that, move one of these hydrogens over here, it takes the bond electrons with it, which is why there's a double-headed arrow, moves the hydrogen over to this carbocation, putting the carbocation on this carbon now, okay? Because this carbon gave up its hydrogen. It's a hydride shift. The hydride, H minus, moved over here. Bond electrons went with it. Carbocation forms. So we're going to get a new carbocation. So now there's a new carbocation there. Let me draw it a little lower. I need some room here. There's a new carbocation there, and one of the hydrogens that were on the benzylic carbon is now on that secondary carbon. Now it's just a carbocation, nothing special about it, except for it's benzylic. Now the solvent can attack the carbocation, and it's going to follow the mechanisms that we've already seen. And now we're going to give the product. And there you go. This product is this one. So let me circle that for you. There you go. That's how you do that. That's how you determine the product right there. All right. Now, I know this is a little weird. I know a little tricky. So you might want to watch the video again, or maybe write it down and maybe work the problem yourself and come back and watch the video again. Make sure you're right. Make sure you've got it. On exams, SN1 or E1 reactions with rearrangements are almost always there. It's something that I put on there just to make sure that you've got it, that you understand it, because rearrangements are a big deal in organic chemistry. Okay? Now, guys, I hope you found that video helpful. If you did, slap that like button. It really does help me as a YouTube creator when you guys like my content. It lets YouTube's algorithm know that I'm doing a good job for you guys out there, helping you learn organic chemistry. If you haven't already done so, please subscribe to my channel. That tells YouTube that I'm doing a good job and helps promote my channel more, and I really do appreciate that. If you know anyone that's struggling in organic chemistry or in general chemistry, let them know my channel exists so maybe they can get some help. Share my content with them. And you know what, guys? As always, I want to wish you good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.